Have you ever wondered how underwater construction is done? It's a world obscured by the depths of the ocean where engineers and divers combine their expertise to build structures beneath the surface. It's not just laying bricks underwater, oh no, it's a complex, intricate process that involves the use of specialized techniques, cutting-edge equipment, and a whole lot of ingenuity. Underwater construction is an engineering marvel that's nothing short of fascinating. It involves creating structures that can withstand not just the weight of the water above them, but also the unique challenges posed by the underwater environment, like pressure differentials and corrosive saltwater. From the construction of offshore oil platforms to the creation of underwater tunnels and the repair of existing underwater structures, there's a whole world of engineering happening right beneath the surface of the ocean. In the next few minutes, we will dive into the fascinating world of underwater construction. Before any construction begins, an in-depth site investigation is crucial. But why, you might ask? Well, it's because the underwater world is full of surprises. Site investigation is the process of exploring and analyzing the seabed conditions to ensure the feasibility of underwater construction. It's like doing detective work, but under the sea. One of the key methods used is sub-bottom profiling, a sonar-based technique that allows us to unveil the mysteries of the underwater world. This technique uses sound waves to penetrate the seabed, providing detailed images of the subsurface layers. It's like having X-ray vision, but for the ocean floor. These investigations help to determine the best approach for the project, whether it's building a bridge foundation or an offshore wind farm. It helps us understand the challenges that might be faced during construction and plan for them accordingly. So, once the site investigation is completed, the actual construction process can begin. It's a vital first step in the journey of underwater construction. Diving and remotely operated vehicles, or ROVs, play a crucial role in underwater construction. Let's take a deep dive, pun intended, into how these two essential components contribute to the success of a project below the surface. Firstly, divers. These brave men and women are the hands-on workforce of underwater construction. Equipped with specialized gear and trained to withstand the pressures of the deep, divers are involved in every stage of the construction process. From the initial site investigation, where they assess the seabed and gather samples, through to the construction phase, where they assist in the assembly and installation of structures. They're also integral in maintenance and repair work, performing tasks that require a human touch. But there's a limit to what a diver can do. The deeper you go, the more challenging and dangerous it becomes for human divers. That's where ROVs come in. These unmanned, remote-controlled machines are the superheroes of the deep, capable of reaching depths and locations too dangerous or inaccessible for divers. They're equipped with cameras and a variety of tools to carry out detailed inspections, conduct surveys, and even perform construction tasks. In the site investigation phase, for example, ROVs can create detailed maps of the seabed, identify potential hazards, and collect samples from depths that would be risky for divers. During construction, they can assist with tasks like welding and cutting, and in the maintenance and repair phase, they can perform inspections and carry out repair work on damaged parts of the structure. But it's not just about the depth. ROVs can also work in harsh conditions like strong currents that would make it difficult for divers. They can operate around the clock, and they're not affected by decompression sickness or other health risks associated with deep-sea diving. Whether human or machine, these underwater explorers are essential to the success of any underwater construction project. By working together, divers and ROVs ensure that we can build, maintain, and repair structures in the challenging environment of the deep sea. There are several specialized techniques used in underwater construction. As we delve deeper into this fascinating world, we find that the artistry of engineering truly shines when faced with the challenge of building beneath the water's surface. One of the key techniques employed in underwater construction is the caisson method. This method is as intriguing as its name suggests. Caissons are watertight structures or chambers that are made on the surface, then sunk into the water. Once submerged, they're filled with concrete to displace the water and create a stable, dry environment where construction can proceed. The caissons serve as foundations for structures like bridges or piers, providing solid support in the unpredictable environment underwater. Next up is the cofferdam method. This is another ingenious technique that engineers use to keep water at bay. A cofferdam is essentially a temporary enclosure built within the water body, designed to allow the enclosed area to be pumped dry. This creates a suitable dry work environment underwater. Cofferdams can be made from a variety of materials including steel, concrete, or even earthen embankments. Once the construction within the cofferdam is complete, the enclosure is removed and the water reclaims its place. Now, let's talk about underwater concrete, a material that sounds like a contradiction in terms but is a testament to the innovation of engineers. Underwater concrete is specially designed to set and harden underwater, making it a crucial component in many underwater construction projects. It's created by using additives that minimize washout of cement and fines, ensuring the concrete remains intact even when submerged. This concrete can be placed by divers or pumped through a tremie, a long pipe that reaches the seafloor, ensuring accurate placement. These techniques are not without their challenges, of course. The caisson method, for instance, requires precise placement and can be disrupted by unpredictable underwater currents. The cofferdam method, on the other hand, is limited in terms of the depth at which it can be effectively used, and while underwater concrete is a fantastic innovation, it requires careful handling and precise placement to be effective. However, despite these challenges, these techniques have proven to be exceptionally effective in the construction of underwater structures. From the foundations of mighty bridges to the walls of underwater tunnels, these methods have been instrumental in turning the seemingly impossible into the possible. In the face of the vast, unpredictable ocean, engineers have risen to the challenge, using these techniques to build beneath the waves. They've mastered the art of working with, rather than against, the unique challenges that the underwater environment presents. And in doing so, they have expanded our horizons, pushing the boundaries of what we thought possible. These techniques, while challenging, allow engineers to construct complex structures beneath the water's surface. And as we continue to explore and understand our world, who knows what marvels of underwater construction the future may hold. Underwater construction is not without its challenges. It's a realm where human ingenuity meets the raw, unforgiving might of nature. But with every challenge comes an opportunity for innovation, and that's what engineers thrive on. One of the primary hurdles in this field is dealing with pressure differences. As we plunge deeper into the ocean, the pressure increases exponentially. This can affect both the human divers and the materials used in construction. But engineers have found ways to counter this. They use special materials and construction techniques designed to withstand these intense pressures, ensuring the safety and structural integrity of the underwater structures. Visibility, or rather lack of it, is another significant challenge. The deeper we go, the darker it gets, and at great depths it's pitch black. This poses an immense challenge to construction, as visibility is key to precision. Engineers have developed advanced lighting systems and utilized remotely operated vehicles equipped with cameras to navigate these murky waters. Then there's the risk of decompression sickness, a potentially fatal condition that can affect divers who surface too quickly. To mitigate this, engineers have introduced saturation diving. In this technique, divers live in a pressurized environment for several days, allowing their bodies to become saturated with inert gases at the pressure of the depth they will be working at. This allows for longer working periods underwater and a safer return to the surface. But what about the impact on marine life? Engineers are always mindful of the delicate balance of the ocean ecosystem. That's why they use environmentally friendly materials and construction methods that minimize disruption to marine habitats. Despite these challenges, engineers continue to push the boundaries of what's possible in underwater construction. They don't see these obstacles as roadblocks, but rather as stepping stones to greater innovation. After all, in the words of the great engineer Henry Ford, when everything seems to be going against you, remember that the airplane takes off against the wind, not with it. So, that's a brief dive into the world of underwater construction. We've navigated through the intricate process of site investigation, understanding its crucial role in laying the groundwork. We've plunged into the depths with divers and remotely operated vehicles, witnessing firsthand the eyes and hands of engineers beneath the waves. We've explored the ingenious techniques employed in underwater construction, marveling at the ingenuity of human inventiveness. Lastly, we've surfaced to the challenges faced in this unique field of engineering and the innovative solutions that address them. Underwater construction is a testament to human determination and creativity, pushing the boundaries of engineering and technology. It's a world where precision, resilience, and innovation converge to create structures that defy the odds and withstand the test of time. Next time you see an offshore structure or a bridge pier, you'll have a better understanding of the engineering marvels that lie beneath the water's surface.